A nearly face-on whirlpool in Centaurus catches the eye because its spiral arms don't obey the usual rulebook. In most disks the arms trail the direction of rotation, but this system's two bright outer lanes point the same way the stars are turning, while a fainter inner arm wraps the opposite way. Subtle dust silhouettes and color gradients across the face of the disk reveal which side is nearer to us, and from that geometry the spin comes out clockwise. The outer pair are truly leading, not trailing illusions. The galaxy's classification, SAR, telegraphs a lot of its anatomy at once: unbarred, ringed, with moderately tight arms growing from a smooth, old stellar bulge. The ring girdling the inner disk is packed with H2 knots and compact blue clusters, a sign that gas has been herded into resonant lanes where star formation turns on like lights along a rotating avenue. Kinematically the system sits a few hundred million light-years away, its recession speed on the order of a few thousand kilometers per second, and its inclination is so small that the disk is almost a coin facing us, exactly the viewpoint that makes nearside dust tests delicate and the leading arm verdict so striking. Why would a stellar city flaunt forward-pointing arms? Dynamics in rotating disks offer several paths. A glancing encounter with a smaller companion can torque the disk and punch up a ring while briefly flipping the sense of one spiral mode. The bright, slightly lopsided outer lanes and patchy star-forming clumps fit that playbook. In such events, different wave patterns can coexist: a robust M=2 mode that winds one way in the outer disk and a weaker counterwinding pattern closer in. Because shear in a differentially rotating disk tends to unwind leading structures, this arrangement is expected to be transient on timescales of tens to a few hundred million years unless continually driven. Bars can do the driving too, but here the absence of a clear bar suggests either a dissolved bar, a lens-like oval too subtle to spot at this inclination, or an external perturber as the main culprit. The ring itself likely sits near a resonance where the pattern speed of the spiral matches orbital frequencies, so gas clouds stall, pile up, and ignite. Measured across many spirals, such rings often sit near inner Lindblad or ultraharmonic resonances, and the tidy circle in this disk looks like a textbook case. The reverse winding spiral is also a population mosaic. The central bulge glows redder, a signature of older, metal-rich stars, while the outer lanes host fresh clusters whose colors drift from blue to slightly greener hues downstream of dust lanes, an age sequence imprinted by the passage of gas through the density crest. Pitch angles differ between the inner and outer patterns, hinting that distinct dynamical engines are at work across radius. Even the dust is a clue. Its faintness compared to gas-rich grand design spirals suggests a relatively modest present-day gas reservoir, yet what gas there is has been organized efficiently by the ring and arm resonances. In the background, the dark matter halo supplies the scaffold that sets the overall shear. Leading patterns survive longest when the halo and disk conspire to keep the pattern speed and resonances in a gentle balance. If this balance tilts, the outer arms should evolve back toward trailing, erasing the oddity and returning the disk to something more ordinary. Context matters. The clockwise whirl lives in a busy region where galaxy flybys are common, and its outer disk shows the mild asymmetries, one arm a little brighter, one side of the ring a touch knottier, that betray tidal nudges. Long exposure images reveal low-contrast plumes and ripples at the surface brightness limits, debris that likely traces the path of a swallow dwarf. Spectroscopy across the face of the disk finds orderly rotation with only small deviations, no violent shocks, more like a stirred teacup than a shaken bottle, supporting the picture of a minor, not major, interaction. Pattern speed estimates fall in the familiar, tens of kilometers per second per kiloparsec range, placing corotation comfortably outside the ring so that star-forming gas keeps flowing into the resonance rather than being flung past it. Over cosmic time that inflow can build the inner disk and subtly reshape the bulge, showing how even a peculiar geometry still feeds the quiet metabolism of a spiral galaxy. Seen this way, the Centaurus oddity is less a paradox than a snapshot of spiral structure in motion. Spiral arms are not solid things, they are waves, amplifications, and guided traffic patterns for gas and stars. When a perturbation arrives, an off-center tug, a pulse of accreted gas, the disk can host more than one wave at once, each with its own winding sense and radial domain. The reverse winding disk makes that abstract idea visible, a bright, forward-pointing outer pattern braided with a faint, backward-wrapped inner one, a resonance ring where the traffic slows and glows, and a bulge that remembers earlier epochs of assembly. Call it the reverse winding spiral, the ringed contrarian, the clockwise whirl, the Centaurus enigma. The names can change, but the lesson endures. Even in a universe of governing principles, rotating disks remain improvisers, and sometimes the music of their patterns plays surprisingly, gloriously, backward. The eccentric pinwheel also rewards patience with technique. To decide which side is nearer when the disk is almost face-on, astronomers don't rely on a single cue, they stack weak indicators until the geometry snaps into focus. Dust lanes look a shade darker on the near side because they veil the stellar light before it reaches us, star colors shift subtly where extinction bites, and even the silhouettes of small clouds against the bulge whisper which edge tilts our way. Kinematics finishes the story. A gently rising rotation field across the face tells you which quadrant is coming toward us and which is receding. Combine the near-side test with the velocity map and the spiral handness falls out cleanly, leaving the outer arms undeniably forward. That result alone would be enough to make the Centaurus enigma famous. The twist is that the inner disk hosts a weaker counterwinding pattern at the same time, two superposed waves sharing one rotating canvas. Spiral structure lives and dies by resonance. Gas clouds orbit with the galaxy's angular frequency, while the spiral pattern turns with its own speed. Where these frequencies line up, near inner Lindblad, corotation, or ultraharmonic resonances, traffic slows, piles up, and ignites. The ring girdling the clockwise whirl is a showcase of that choreography, a near-perfect circle studded with H2 regions and compact blue clusters, like pearls spaced by the orbital period. Downstream from each dust lane the newborn clusters drift and age, and their colors trace a clock that, together with the rotation curve, lets you back out the pattern speed. Measured this way in many spirals, pattern speeds land in the tens of kms superscript 1 kpc superscript 1 regime. The reverse winding disk behaves no differently in principle, only the phasing of its outer mode has been flipped by a perturbation. That perturbation could be an off-center flyby or a swallow dwarf, both common in a crowded environment. A lopsided light distribution, an m=1 mode, faint outer ripples, and one outer arm that runs a bit brighter than its twin are classic calling cards of a recent tidal nudge. In simulations, such encounters can momentarily amplify a leading wave in the outer disk while leaving the inner disk to host a trailing mode, exactly the counterwinding arrangement we see. Differential shear will try to unwind the forward pattern. Unless a driver keeps pushing, swing amplification will convert any surviving leading piece into a trailing one on timescales of a few times 10 years. That makes the ringed contrarian a snapshot of a transient state, rare not because physics forbids it, but because the window to catch it is brief. Star formation along the ring is efficient because the gas is compressed near resonance. Giant molecular complexes assemble into beads that later fragment into clusters. Their luminosity function follows a power law with the brightest knots marking sites of recent, massive births. If you line up ultraviolet, H-alpha, and mid-infrared maps, you see the sequence of dust heating and ionization march azimuthally away from the shock ridge, another clock for the pattern. Gas phase metallicity typically declines with radius in spirals, but resonant rings stir azimuthal flows and can flatten local gradients. The backward spiral's tidy circle is therefore not just pretty, it is a machine for mixing. Over hundreds of millions of years this conveyor belt builds the inner disk, feeding the bulge at a pace dictated by torque and dissipation rather than by cataclysm. The bulge itself sits between archetypes. Its light falls off more steeply than a pure exponential disk yet not as sharply as a classical elliptical core, hinting at a Cirsic index in the middle ground. Without a strong bar, secular inflow is slower, which fits a picture where minor interactions and resonances, not a dominant bar, have taken the lead in shaping the center. A central black hole almost certainly anchors the nucleus. The scaling between bulge dispersion and black hole mass makes that expectation mundane rather than exotic, and low-level activity could flicker in radio or X-rays even if the optical spectrum looks quiescent. In a galaxy defined by pattern physics, the nucleus is an anchor point more than a protagonist. Magnetic fields lace the disk and trace the spiral geometry in polarized radio continuum. In most grand design spirals, the field lines follow the trailing arms with a modest pitch angle. In the reverse wound pinwheel they must negotiate a more complex flow. Compression in the ring will align and strengthen the ordered component, while shear at the interface between counterwinding modes may twist the field and seed turbulence. That turbulence, in turn, governs how cosmic rays and thermal gas diffuse out of star-forming knots, which is why radio maps can look smoother than the clumpy H-alpha arcs. The particles and fields smear the signal across the interarm space. Even here the galaxy's odd arm sense doesn't break the rules, it simply rearranges where the familiar processes play out. The dark halo, silent and massive, sets the tempo. Spiral waves grow best when the disk is cool enough to be responsive, Q of order unity, but supported enough to avoid collapse. The halo's gravity helps keep the rotation curve flat while the disk's self-gravity and feedback from star formation regulate Q. In this balanced regime, a passing satellite can inject just enough asymmetry to light up a leading wave without tearing the system apart. If the perturber also carried gas, a whiff of counter-rotating material could survive in the outskirts, revealed by a slight misalignment between stellar and gaseous angular momenta. Integral field spectroscopy can test that, map the stellar absorption lines and nebular emission across the face, compare their velocity fields, and look for twists that betray kinematic decoupling. Because the disk is nearly face-on, measuring thickness and warps is tricky, but vertical structure still leaves signatures. A recent minor merger puffs the outer disk, warming stellar motions and slightly broadening spectral lines. Resonant rings can trap stars and build lens-like components that mimic the start of a bar without ever finishing it. Deep imaging can also expose ultra-low surface brightness shells or plumes, fossils of an accretion event, that line up with the direction from which the culprit arrived. The clockwise whirl's mild asymmetries and ring perfection together suggest a small intruder and a clean pass, enough torque to flip the phasing of one spiral mode, not enough violence to shatter the grand design. Even the timing of stellar births becomes a probe. If you date clusters along a single outer arm, ages should increase steadily with angular distance from the dust lane. The slope of that age-angle relation, multiplied by the circular speed at that radius, yields the difference between orbital and pattern speeds. Do this at multiple radii and you can watch the pattern evolve, searching for evidence that the forward-pointing wave is decaying as theory predicts. Catch it again millions of years from now and the Centaurus oddball should look more conventional, its outer arms trailing once more, its ring dimmer as gas depletes or migrates inward. Multi-wavelength eyes complete the portrait. Cold atomic gas spreads farther than the starlight and can reveal tidal tails invisible in the optical. Carbon monoxide traces the dense phase that actually forms stars and shows whether the ring is a long-lived reservoir or a fast-throughput conveyor. Mid-infrared dust emission lights up embedded nurseries that the optical misses, while far-infrared measures the total energy reprocessed by grains. X-rays mark remnants of massive stars and the hottest bubbles carved by stellar winds, giving a time-integrated view of star formation over tens of millions of years. Fold these views together and the ringed contrarian stops being a curiosity and becomes an empirical laboratory for pattern lifetimes, resonance fueling, and disk resilience. Call it the reverse-winding spiral, the Centaurus oddity, the ringed contrarian, the clockwise whirl, the offbeat carousel. Names are only handles for a deeper lesson. A spiral galaxy is a self-organizing flow subject to nudges from neighbors and from its own internal instabilities. Most of the time those flows arrange themselves into trailing arms because shear prefers them. Occasionally, as if to remind us that dynamics allows improvisation, a perturbation flips the phase and we catch a forward-pointing wave in the act. The backward galaxy is that improvisation, frozen in a moment long enough for us to read it, and fleeting enough that we know we're watching pattern physics in motion rather than a different kind of galaxy altogether. Tilt the view in your mind and imagine following a single parcel of gas in the two-faced spiral as it rides the disk. It orbits into a dust ridge, is squeezed and cooled, collapses into a clutch of newborn stars, and then drifts downstream while supernovae and stellar winds puff cavities into the interstellar medium. Because the pattern itself rotates more slowly than the stars, the cluster ages as it slides away from the shock. That aging gradient becomes a ruler you can lay against the arm to time the traffic. Where the ringed contrarian gathers material near resonance, the ruler reads in neat, repeating ticks, a chronograph built from blue clusters fading to white and then to the gold of older populations. The clockwise pinwheel is also a workshop for disk stability. In regions where gravity, rotation, and pressure balance just so, the tumor parameter hovers near unity and the disk is exquisitely responsive to even a gentle nudge. That's why a minor flyby can seed a forward-winding wave without wrecking the structure. If the disk were much hotter dynamically, perturbations would smear into nothing. If it were too cold, it would splinter. The Centaurus oddity sits in that narrow, just right, band where swing amplification takes a faint disturbance and sculpts it into a grand pattern, here, peculiarly, one that points ahead of the rotation in the outskirts while an inner mode still wraps the conventional way. The ring-laced carousel doesn't only sort stars by age, it mixes metals by design. Gas streaming through a resonance lingers, rubs shoulders with material from slightly different radii, and erases sharp chemical contrasts. Over a few rotation periods the azimuthal variations flatten and the radial gradient softens locally. That mixing matters. It sets the composition of the next generation of stars and the cooling efficiency of the gas, which in turn feeds back on how easily new clouds collapse. In a galaxy where patterns have been rearranged, chemistry becomes a tracer of the recent dynamical script. Look closely at the nucleus of the reverse-winding disk and you find the quiet authority of a central mass. Even in the absence of a showy bar, torques from spiral structure and the ring can trickle gas inward, building a compact, slightly disky component around the bulge. A modest black hole likely anchors the core. It need not blaze to influence its surroundings, because the mere correlation between bulge gravity and stellar motion sets boundary conditions for how waves propagate. The center, in that sense, is a metronome, steadying the rhythm while the arms improvise. Magnetism threads the offbeat carousel and responds to the same flows that herd gas into lanes. Compression along the resonance sharpens and aligns the ordered field, while shear between the counterwinding modes twists lines and stirs turbulence. Cosmic ray electrons, surfing those fields, smear the memory of individual star-forming knots into smooth radio ridges that hover just off the optical dust lanes. The mismatch between clumpy H2 arcs and more continuous radio strands is not a contradiction, it is a map of how energy and particles diffuse through a living disk. Because the clockwise whirl is almost face-on, vertical structure hides in plain sight, but it leaves fingerprints. A slightly warmed outer disk, thicker stellar scale height, broader absorption lines, whispers of past minor accretion. Lens-like light in the inner few kiloparsecs suggests stars trapped by resonances, a fossil of pattern-driven evolution rather than a classical bar. Push deeper with long exposures and the background reveals wisps at the edge of detectability, the kind of low-surface brightness plumes that act as chalk marks on the cosmic sidewalk where a small companion once crossed. Kinematic cartography ties the story together. Map the line-of-sight velocities of stars and gas across the face of the ringed contrarian and the rotation field tilts just enough to label approaching and receding sides. Combine that with the near-side dust cues and the sense of spin becomes unambiguous, which is why the outer arms cannot be hand-waved back into the usual trailing set. Decompose the light into harmonic spirals and you see multiple modes at once, a strong M equals 2 pattern outside, a subtler counter-spiral inside, each with its own pitch angle and phase. The disk is not confused, it is polyphonic. Time, finally, is the secret protagonist. Leading waves do not last forever in a differentially rotating disk. Shear gnaws at their phasing until amplification flips them, unless a driver, ongoing tidal nudges, a drip of accreted gas, an oval distortion, keeps feeding the anomaly. That inevitability is what makes the Centaurus enigma precious. It is a candid shot between rehearsals, a caught-in-the-act demonstration that spiral structure is not a fixed ornament but a conversation between gravity, rotation, and memory. Catch the backward-looking whirl again after a few 100 million years and the outer lanes may have relaxed into the orthodox trailing choreography, the ring dimmer as its gas migrates inward, the disk a touch rounder from the mixing it has endured. Until then, the counterwinding mosaic keeps playing its bright, asymmetric melody, a resonance ring glowing like a necklace of H2 pearls, a forward-pointing outer duet braided with a quietly trailing inner refrain, a nucleus beating time, and a halo holding the stage steady. Call it the reverse-winding spiral, the Centaurus oddity, the ringed contrarian, the clockwise spinner, the offbeat carousel, whatever label you favor, the lesson is durable. Spiral arms are patterns, not objects, and patterns can surprise you without ever breaking the rules. Rarity is part of the allure. Most face-on spirals advertise trailing geometry so clearly that selection effects work against finding counterexamples. Dust silhouettes, color gradients, and velocity tilts have to be read with care, and any ambiguity usually defaults to the orthodox interpretation. The clockwise spinner breaks that habit, not because the rules are different here, but because several faint clues line up the same way. In surveys of nearby disks, convincing outer leading patterns are uncommon, likely fleeting, and preferentially associated with mild asymmetries or rings, signposts that a recent nudge has passed through. The ring is a metronome for gas. Clouds stream in, feel a resonant tug, slow, and compress. Beads of star formation light up in sequence, and feedback from massive stars blows cavities that merge into filigreed arcs along the inner edge. Hot bubbles vent vertically as fountains, rain back as cooler filaments, and in doing so they shuffle metals azimuthally, softening any sharp chemical contrasts. Local shear sets the spacing of the brightest clumps, pressure balance fixes their thickness, gravity decides which beads collapse again to seed the next round of clusters. The result is a living beltway where physics repeats in miniature each time a cloud completes another lap. The counterwinding duet is a dynamical compromise. A strong two-armed mode dominates the outskirts with the unusual phase, while a subtler inner spiral wraps the familiar way. Where they meet, interference alters pitch angles and skews dust ridges, giving the eye the impression of a twist inside the disk. In a differentially rotating system, leading segments want to shear forward into trailing crests unless energy and angular momentum continue to be fed into the wave. That is why a small, recent perturbation is the most economical explanation. It injects just enough asymmetry to light up the forward pattern without shredding the grand design. A good test bed invites experiments. Map the nebular emission across the outer lanes and plot cluster ages against azimuthal angle. The slope should encode the gap between orbital and pattern speeds and, crucially, the direction of drift should confirm the forward phasing. Compare stellar and gaseous velocity fields for a tiny twist in kinematic position angle that would betray residual misalignment from a flyby. Trace cold atomic gas beyond the optical disk to look for low-contrast tidal streamers. Follow carbon monoxide in the ring to see whether the belt is a through-flow conveyor or a long-lived reservoir. Measure polarized radio continuum to watch magnetic vectors hug shock fronts on the side expected for a leading wave, and look for smoother radio ridges offset from clumpy H2 arcs as cosmic rays smear the memory of star births. Secular evolution rides piggyback on these patterns. Even without a strong bar, torques from spirals and the ring bleed angular momentum outward and mass inward, thickening the inner disk and subtly resculpting the bulge. Stars trapped near resonances build lens-like light distributions that can be mistaken for weak bars seen face-on. In a system this close to face-on, such lenses are easier to grow than to diagnose. Over gigayear timescales, repeated episodes of mild accretion can layer these imprints like tree rings, each one recording the phase and reach of a past wave. Environment provides motive and opportunity. In a crowded neighborhood, flybys and minor captures happen often enough that most disks wear at least one faint scarf of debris if you look deeply. The offbeat carousel's slight brightness and balance between its outer arms and the near perfection of its ring together suggest a clean, recent pass by a small intruder, enough torque to flip the phase of one mode, not enough to trigger a wholesale starburst or a bar. The same encounter likely puffed the outer disk by a small amount, warming stellar motions while leaving the rotation field orderly. Energy flows through the medium in layered channels. Shocks at dust ridges convert orbital energy into heat, cooling reorganizes that heat into radiation, turbulence, and the work of climbing gravitational wells inside collapsing clouds. Young stars return a fraction of that energy via winds, radiation pressure, and supernovae, maintaining a floor of agitation, turbulent pressure that helps keep the disk marginally stable. Magnetic fields tap shear to grow ordered components that thread the arms, while cosmic rays stream along those lines and quietly ferry energy into interarm space. None of this depends on which way a pattern points, the surprise is purely geometric, the engine underneath familiar. Time will smooth the eccentricities. If the forward wave is not fed, shear will unwind it, the outer lanes will relax into trailing geometry, and the ring will either dim as gas depletes or migrate as resonances shift. The nucleus will grow a little denser, the inner disk a little more lens-like, and the outermost ripples will fade below reach except in the deepest exposures. What will remain are fossils in phase space, subtle correlations of stellar ages, orbits, and metallicities that remember where the resonances sat and how long the counterwinding duet played. Until that future arrives, the Centaurus oddity is a generous teacher. It shows that spiral structure is a conversation between gravity and memory, that waves can share a disk without confusion, and that a single, well-timed disturbance can rephrase the music without changing the instrument. Call it the reverse winding spiral, the ringed contrarian, the clockwise pinwheel, the offbeat carousel, the labels are handles on a more durable truth. A galaxy is not a static picture but a self-organizing flow, and even when it appears to run backward, it is simply exploring the full grammar of rotating matter. Observers who chase subtleties find more than a curiosity, they find a laboratory for how orbits trade energy and angular momentum. In the offbeat carousel, stars on nearly circular paths drift radially when they skim corotation with the spiral, churning that shuffles them without heating the disk very much, while epicyclic, blurring, thickens the population. A forward-phased outer wave changes the geometry of those exchanges, the direction of systematic drift across the crest flips, so the imprint on metallicity and age patterns around corotation flips too. Map the chemistry in fine azimuthal slices and you should see the telltale alternation, slightly metal-richer pockets just downstream of dust ridges where recycled gas congregates, then smoother, better mixed sectors where the wave's grip weakens. Over hundreds of millions of years this quiet migration irons creases into the radial gradient and grows lens-like components in the inner disk without ever needing a bar. The contrarian spiral is equally instructive for resonance cartography. Tremaine-Weinberg measurements with stellar absorption or CO emission can anchor the pattern speed, rings and breaks locate the inner Lindblad and ultraharmonic resonances. A corotation circle emerges where material stops overtaking the crest and rides alongside it. In a two-mode, counterwinding system, those features come in pairs or gently misaligned ellipses, a signature that the disk hosts overlapping waves with different pitches and phases. Draw the resonance map and a story appears, an outer mode driven or amplified by a recent nudge, a quieter inner mode shepherding gas toward the ring, and a nucleus acting as a rigid anchor that reflects waves rather than absorbing them. Cold gas extends the narrative beyond the starlight. Neutral hydrogen in the outskirts is the first to betray a disturbance, its surface density ripples and kinematic twists remember flybys long after the optical disk looks serene. Molecular gas in the ring reveals whether the belt is a fast-throughput traffic circle or a semi-permanent depot, narrow lines and orderly streaming point to quick turnover, broader, multi-component profiles hint at cloud crowding and repeated shocks. Either way, the bead-like spacing of H2 regions encodes the local balance of shear and pressure, while mid-infrared emission from aromatic grains sketches the web of UV light leaking out of young clusters. Layer these tracers and the ring stops being a pretty circle and becomes a flow diagram you can read. Seen almost face-on, thickness and warps hide, but stellar dynamics bring them back into view. A minor capture puffs the outer disk, raising vertical velocity dispersion and slightly broadening absorption lines at large radius. a gently heated population also softens the sharpness of the outer edge, replacing a hard truncation with a more forgiving taper. If a whiff of counter-rotating gas survived the encounter, the gaseous kinematic position angle will show a tiny twist relative to the stars, an elegant, falsifiable clue that the perturber did more than tug, it left behind a few angular momentum calling cards. Magnetism, often the quietest actor, becomes a clean diagnostic when geometry turns unusual. Ordered fields align where gas is compressed, and polarized radio ridges typically sit just off the optical dust lanes on the downstream side for a trailing wave. In the clockwise pinwheel's outskirts, the offset should reverse, with the polarization crest marching to the other side of the lane. Measure that flip and the arm sense is confirmed without touching dust silhouettes or color gradients, a check independent of extinction, valuable precisely because the disk is so close to face-on. Environment keeps the plot moving. A spiral embedded in a bustling neighborhood endures a spectrum of nudges, slow tidal flybys that launch long-wavelength lopsidedness, quick harassments that rattle the outer gas, and gentle ram pressure that trims the most fragile HI skirts. The ringed contrarian looks like a system that met a small passerby on a clean trajectory, enough torque to light a forward-phased mode, not enough violence to ignite a global starburst or carve a strong bar. Deep exposure should still find whispers of the meeting at the edge of detectability, ultra-faint plumes, scallop ripples, or a one-armed asymmetry that refuses to fade completely. What makes the clockwise spinner compelling is not that it violates any rule, it clarifies the rules by testing their boundaries. Differential rotation still favors trailing waves, swing amplification still turns leading seeds into trailing crests unless a driver keeps pushing, resonances still herd gas, light rings, and build inner structure. Here, for a limited window, phasing is flipped where the disk is most responsive, and the eye can watch how the same old physics paints a different mural when one sign changes. Date clusters along an arm, watch ages increase with azimuth in the direction that only a forward pattern allows, extract a pattern speed from that slope, and you have timed the choreography directly. Projecting forward, the counterwinding duet is unlikely to be permanent. As the external torque fades and gas circulates, the outer wave should unwind into orthodoxy, the ring should damn or drift as resonances shift, and the inner disk should preserve the memory as a smoother lens, a slightly rounder bulge, and a gentler metallicity gradient. Long after the offbeat geometry has relaxed, those fossils will persist in phase space, correlations between orbit shape, age, and chemistry that reveal where corotation once sat and how vigorously the wave mixed the disk. Call this galaxy the reverse winding spiral, the ringed contrarian, the clockwise pinwheel, the Centaurus oddity. The name is a handle on a deeper lesson. Spiral arms are patterns in a responsive medium, not fixed material ribbons. Change the forcing, change the phase, and the same medium composes a new theme without changing instruments. Catching the theme mid-transition, as we do here, is the gift. It turns a pretty picture into a dynamical experiment, and a single, face-on whirl into an essay about how rotating matter remembers, forgets, and writes itself again. Future eyes will keep squeezing truth out of the reverse winding pattern by comparing how different tracers lag or lead one another. Ultraviolet light spotlights the youngest stellar knots tucked just downstream of dust ridges. H-alpha marks the few million-year window when massive stars ionize their birth clouds. Mid-infrared highlights warm dust and aromatic grains that glow where UV photons leak, and radio continuum smooths everything as cosmic ray electrons diffuse along magnetic fields. The offsets between these maps are not decoration, they are rulers. Measure them arm by arm and you can reconstruct shock strengths, gas flow speeds, and the cadence at which clouds are compressed, collapse, and are blown apart again by feedback. In a forward-phased outer wave, those offsets flip to the other side of the dust lane compared with orthodox trailing spirals, letting geometry alone predict where each tracer should sit. Cold gas adds another layer to the score. Neutral hydrogen in the outskirts is a historian with a long memory, carrying ripples and kinematic twists long after starlight pretends calm. Molecular gas in the ring is the present tense, condensing into giant complexes whose masses span orders of magnitude and whose spacing reflects the local balance of gravity, shear, and pressure. If the ring is a fast-throughput beltway, line profiles look narrow and streaming motions are clean. If cloud crowding dominates, profiles broaden into multiple components and shocks repeat as traffic backs up. Either way, the bead-like pattern of H2 regions is a living diagnostic. Its regularity tells you the resonance is stable, its asymmetries whisper how recent the nudge was that set the wave glowing. Dust chemistry is a quiet narrator of environment. Aromatic features strengthen where radiation fields are intense but not destructive. Silicate absorption deepens where lines of sight cross cooler, thicker lanes. Sub-millimeter emission pinpoints the coldest reservoirs that tomorrow's clusters will mine. Because a counterwinding duet mixes gas azimuthally, sharp contrasts in dust temperature and grain charge are softened around the ring, while small, stubborn pockets persist where the inner and outer modes interfere. Track those pockets across the disk and you can map where the waves add and cancel, a kind of interference topography written in soot and ice. Stars respond on slower timescales and leave fossils in their orbits. Corotation churning shuffles them radially with little heating, while epicyclic blurring thickens the disk. A forward-phased wave flips the sign of the systematic drift across the crest, so the imprint in age and metallicity around corotation flips too. Later, when the geometry has relaxed into trailing orthodoxy, that fossil survives as a subtle, azimuthally modulated gradient, a memory encoded not in a photograph but in phase space. Peel that memory back with integral field spectroscopy and chemodynamical modeling, and you recover the tempo at which the odd pattern evolved. The nucleus keeps time while the ring does the dancing. Gas shepherded inward by spirals and mild oval flows builds a compact, slightly disky component embedded in the bulge, feeding a central black hole at a whisper rather than a roar. Even low-level accretion can seed a faint radio core and a sprinkle of X-ray binaries, with ultraluminous X-ray sources flaring where young clusters are densest along the ring. Those high-energy tracers complement the optical and infrared clocks. They measure the short, bright lifetimes of massive stars and the endpoints of close binary evolution, tying feedback to structure with a stopwatch's precision. Magnetic fields do not stand aside, they choreograph along with gravity. Compression at shocks aligns and strengthens ordered components, shear between counterwinding modes twists them, and turbulence seeded by feedback tangles them again. The result is a polarized radio map that offsets from optical dust lanes in a manner that encodes arm sense without ever touching extinction. Where the outer forward wave dominates, the polarization crest lands on the unexpected side. Where the inner trailing mode takes over, the familiar offset returns. A single galaxy thus offers both cases side by side, an elegant A-B test for magnetohydrodynamic theories of spiral disks. Even vertical structure, hard to see in a face-on system, leaves fingerprints. A gently warmed outer population broadens absorption lines at large radius and softens the disk edge from a sharp truncation to a tapered fringe. Fountains driven by clustered supernovae lift hot gas above the plane and rain it back as cooler filaments, stitching a faint, diffuse halo that glows in soft X-rays and scatters H-alpha like a thin veil. If a minor capture supplied a thread of counter-rotating gas, the gaseous kinematic position angle will tilt by a few degrees relative to the stars, a delicate but testable sign that the perturbation did more than raise tides, it left behind calling cards of angular momentum. None of these pieces require new physics, they require patience and a willingness to read a disk as a flow rather than a picture. Spiral arms are traffic patterns, not material braids, rings are resonant bottlenecks, not ornaments, bulges are slow journals written by many episodes of inflow. Flip the phase of one mode and the same grammar writes a different paragraph. That is the lesson the clockwise pinwheel offers, dynamics is permissive, not capricious. Given a nudge at the right time and radius, a disk will host a forward-pointing wave in the outskirts while an inner mode keeps to tradition, and the two will trade energy through resonances until the imbalance fades. Project the story forward and you can sketch the epilogue. As the external driver ebbs, shear will unwind the leading outer crests into trailing geometry, the ring will dim or drift as pattern speed and resonances evolve, the inner disk will grow smoother, lens-like, and the bulges shade rounder. The deepest plumes will sink below easy reach. What remains, long after the headline geometry has relaxed, are the fossils, a flattened metallicity gradient along the old ring, a slight asymmetry in stellar velocity dispersions where the waves once overlapped, a polarization map that still hints at past twists, and a generation of clusters whose ages march with azimuth in a way that only a forward-phased past could have arranged. Call the system the reverse-winding spiral, the ringed contrarian, the clockwise spinner, the offbeat carousel. Names are shorthand for the same durable idea. A galaxy is a self-organizing medium exploring the full grammar of rotation, gravity, pressure, and memory. Most of the time the syntax yields trailing arms. Now and then, a well-timed disturbance flips a sign, and the prose runs backward without breaking a single rule. Watching that paragraph being written, line by line around a luminous bulge and a pearl-strung ring, is less a curiosity than a privilege, a chance to see pattern physics at work in real time on a canvas 100,000 light-years wide. Even gravity's bookkeeping leaves fingerprints in the backward-looking spiral. Where the crest of the pattern and the peak of the mass distribution are slightly out of sync, a phase shift appears, and that offset is a torque engine. On one side of corotation it saps angular momentum from gas and nudges it inward, on the other it donates angular momentum and encourages outward drift. Flip the phasing to a forward pattern and the signs of those nudges flip too. The result is a subtle rearrangement of traffic. Molecular clouds that would normally be braked now get a gentle push, while others stall and thicken into the bright knots that stud the resonance ring. Nothing mystical is required. It is the same dance of orbits and gravity, only mirrored. Two spiral modes sharing one disk setup beats the way two notes do in sound. The outer, forward phase duet and the inner, trailing refrain slide past each other with slightly different pattern speeds, so the places where their ridges add or cancel drift around the face like slow tides. Where they add, dust lanes look crisper, H2 beads crowd closer, and the eye reads a tighter pitch angle. Where they cancel, the arm looks diffuse and the star-forming pearls space out. Follow those beats for a few 100 million years and you have a movie of mode coupling written as a moving interference pattern on a galactic canvas. Star clusters along the ring carry the ledger of recent history. Their mass function typically follows a steep power law, but the most massive end is capped by environment. Stronger compression and higher gas surface density lift the ceiling, gentler conditions lower it. If the forward-phased wave sharpens shocks on one side of the ring more than the other, the cap will be higher there, and the ultraviolet bright giants will be disproportionately common. A few tens of millions of years later many of those clusters begin to unbind, seeding the inner disk with associations that still remember the azimuth where they were born, faint echoes that, if you sort stars by age, map the ring's clockwork after the lights themselves have faded. Gas obeys its own thresholds. Where the combined pressure of turbulence, magnetic fields, and self-gravity pushes surface density above a critical value, collapse runs away and star formation ignites. Where it sits just below, clouds coagulate and shred without committing. The resonance belt in the contrarian carousel nudges gas over that edge repeatedly, which is why the beads look so regularly spaced. Measure the spacing, and you measure the compromise between shear, which pulls clouds apart, and pressure, which holds them together. Measure the offset between dust crests and emission from newborn stars, and you get a stopwatch for the collapse time as gas flows around the ring. Kinematics completes the portrait. The line-of-sight velocity field across the nearly face-on disk tilts just enough to separate approaching and receding quadrants. The rotation curve rises, flattens, and quietly hands the baton to the dark halo beyond the optical edge. Superposed on that orderly field, small streaming motions mark the spiral shocks, and at the interface where the counterwinding modes touch, those streams twist a few kilometers per second one way or the other. It is a gentle turbulence, the difference between a stirred pond and a storm, evidence for a recent nudge and a disk resilient enough to keep its symmetry. The vertical dimension, usually a secret in face-on systems, still speaks if you listen. A slightly heated outer population broadens absorption lines at large radius, a fountain of hot gas from clustered supernovae blooms above the plane and rains back as filaments that outline invisible magnetic rails. The faintest skin of this halo scatters line emission like a gauze, a reminder that feedback never stays where it starts. If a trace of counter-rotating gas lingers from the last encounter, the gaseous kinematic axis will tilt a degree or two relative to the stars, a delicate signature that angular momentum was not just traded but resorted. Chemistry keeps score as well. Azimuthal mixing around the ring smooths what would otherwise be sharp metallicity contrasts, while the slow, resonance-driven inflow builds a mild plateau just inside the belt. The outer disk, laced by the forward wave, shows tiny sector-to-sector offsets, patches a shade more enriched downstream of the dust ridges where recycled gas pools, then cleaner stretches where the grip loosens. Over time those patterns relax, but not before they imprint a fossil gradient that outlives the visible asymmetries. The nucleus doesn't shout, it sets tempo. Torques from spirals and the oval mass distribution trickle gas inward, layering a compact, disky component atop the older bulge and feeding a central mass at a low simmer. Even without fireworks, that mass stiffens the inner potential and reflects waves, helping the inner trailing mode keep its footing while the outer forward mode plays out. In this way the core is less a destination than a metronome, steadying rhythm as the arms improvise. Project the contrarian forward and the likely epilogue is calm. As the external driver fades, shear will convert the forward crests into trailing orthodoxy, the ring will dim or migrate as resonances drift, and the inner disk will settle into a smoother lens with a rounder bulge. Long after the odd geometry is gone, the memory persists in phase space, a slightly flattened metallicity gradient where the ring once shone, a whisper of enhanced vertical dispersion near the overlap of modes, a polarization map with vectors that still hint at past twists, and a population of clusters whose ages march with azimuth in only one direction, the direction of forward wave and forces. So the ringed contrarian, the clockwise whirl, the reverse winding pinwheel, choose your alias, earns its place not as a rule breaker but as a rule tester. It shows that spiral arms are patterns, not objects, that waves can share a disk without confusion, that a single, well-timed nudge can flip a sign in the equations and the whole mural shifts mood without changing medium. To read it is to watch rotating matter think out loud, rehearsing how it remembers, mixes, and writes itself anew. Think of the offbeat carousel as a textbook that writes in several alphabets at once. One alphabet is geometry, the pitch angle of the arms tightening and relaxing with radius, the ring closing almost perfectly on itself, the faint inner spiral wrapping the conventional way while the outer duet points ahead. Another is timing, the age ladders traced by clusters downstream of dust ridges, the delays between shock, collapse, ionization, and dispersal. A third is kinematics, tiny streaming motions layered on a nearly axisymmetric rotation field, the smallest of twists where overlapping modes exchange angular momentum. Read all three together and you get a narrative, not just a picture, a disk briefly hosting a forward-phased wave because something nudged it at the right radius, the right time. In such a disk, corotation acts like a hinge. Inside that circle, material tends to outrun the crest, outside, the crest glides past the stars and gas. Flip the phasing of the outer mode and you flip the sign of who gains and who loses angular momentum across the arm. That small reversal has outsized effects on how clouds assemble, how long they dwell in compressed lanes, and where the next generation lights up. It also alters where rings are most efficient at gathering gas. The result is the beadwork we see, regularly spaced H2 pearls that betray a delicate balance between shear trying to pull structures apart and pressure plus gravity holding them together long enough to form stars. The ringed contrarian also illustrates how multiple pattern speeds can share one stage. The inner, more orthodox spiral may turn a shade faster than the outer forward wave, so the places where the two add or cancel drift azimuthally, creating slow-motion interference that a deep image freezes only for an instant. Where crests align, dust lanes sharpen, star-forming knots cluster, and the arm looks tighter. Where they misalign, the pattern relaxes and bright clumps spread out. Over a few 100 million years those beat patterns slide around the disk, a visible record of mode coupling rather than a single, rigid geometry. All the while, the interstellar medium runs a closed-loop economy. Spiral shocks convert orbital energy into heat and turbulence, Cooling reorganizes that energy into radiation and the work of collapsing clouds. Newborn stars return a fraction via winds, ionization fronts, and supernovae that excavate cavities and seed new instabilities. Magnetic fields are the quiet accountants, aligning where gas is compressed, twisting where shear dominates, and guiding cosmic rays that smear out the radio glow into smoother ridges offset from the optical clumps. None of these channels care which way a spiral points. They care about gradients, compression, and time spent in the high-pressure lane. The clockwise spinner simply rearranges where those conditions are met. Because the disk is nearly face-on, depth cues must be finessed rather than forced. Dust silhouettes are subtle and colors only slightly reddened on the near side, yet taken together with the faint tilt of the velocity field they settle the sense of spin cleanly. That clarity matters for the central inference. The bright outer arms truly lead. Early skepticism faded not because of a single showy measurement, but because many small, consistent clues refused to agree with the trailing default. The lesson generalizes: in weakly inclined galaxies, certainty is cumulative. If the forward-phased wave is a transient, the epilogue is already being written in the chemistry. Azimuthal mixing around the ring smooths what would otherwise be sharper metallicity contrasts, while gentle inflow builds a plateau just inside the belt. Sector by sector, slightly enriched pockets pool downstream of dust crests where recycled gas lingers, then give way to cleaner spans where the pattern's grip loosens. Long after the arm sense reverts to orthodoxy, that chemical handwriting will survive as a fossil gradient tied to the ring's old circumference. Even the bulge participates, albeit slowly. Torques from the spiral and the oval mass distribution trickle gas inward, layering a compact, disky component atop the older core and feeding the central mass at a low simmer. That mass in turn stiffens the inner potential, reflecting waves rather than letting them plunge to the center, and helping the inner trailing mode hold its shape while the outer forward mode lives out its brief tenure. The nucleus is less a firework than a metronome, keeping time while the arms recast the melody. Look outward and the environment explains the opportunity. In a busy neighborhood, small companions wander close often enough to seed lopsidedness, rings, and warps without tearing a disk apart. A clean, off-center pass can torque the outskirts, ignite a forward-phased mode, and leave behind only the faintest of plumes at the lowest surface brightness. The disk's resilience, its ability to host a dramatic pattern without losing rotational order, speaks to a balanced state, cool enough to respond, warm enough to resist collapse, and supported by a dark halo that keeps the rotation curve flat where the show is brightest. Project the contrarian into the future and the likely arc is gentle. As the external driver ebbs, shear will convert the forward crests into trailing lanes, the resonance ring will dim or drift as pattern speed evolves, and the inner disk will settle into a smoother lens while the bulge rounds a touch. What will remain are memories in phase space, star ages that march with azimuth along the old ring, a slightly flattened metallicity gradient at its radius, a whisper of enhanced vertical dispersion where the two modes once overlapped, and a radio polarization map whose vectors still hint at past twists. By then the nickname will matter less than the lesson it carried. Spiral arms are waves in a responsive medium, and even a brief flip in phase can rewrite the disk's recent history without changing a single law. So call it the reverse winding spiral, the clockwise whirl, the ringed contrarian, the Centaurus enigma, choose the handle you like. The deeper story is that a galaxy is not a static portrait but a negotiation among rotation, gravity, pressure, and memory. Most negotiations end in trailing arms. Occasionally the terms shift, a sign flips, and the prose runs backward for a while. Catching that revision mid-sentence is the gift the oddball offers, a chance to watch pattern physics composing in real time on a canvas 100,000 light-years wide. Machine eyes make the oddball even more legible. With integral field spectroscopy, every spaxel becomes a tiny laboratory. Stellar absorption lines fix the bulk rotation and velocity dispersion, nebular emission traces the freshest ionizing sources, weak shocks register as slight line ratio tilts in diagnostic diagrams. Stack those maps and you see the disk as a flow, not a postcard. Wavelet decompositions tease out arm segments with different pitches at different radii, Fourier phases reveal where crests from the outer, forward-phased mode and the inner, orthodox one cross and trade energy. Feed the whole cube to a chemodynamical model and you can invert for the torque field, where the pattern is giving angular momentum back to the gas and where it is taking it away, without ever assuming the arms are rigid or eternal. The ringed contrarian invites a comparative experiment across wavelengths. Radio interferometers outline the cold scaffolding, neutral hydrogen sketches the low surface brightness outskirts where disturbances linger, while CO emission inventories the dense reservoirs that actually spawn stars in the ring. Mid-infrared bands mark where dust grains are being heated, near UV picks out the most newborn clusters, and far UV shows who has aged out of their ionizing phase but not yet faded into the background. Offsets among these ridges act like stroboscopic marks on a conveyor belt, measure them, and you time the shock, collapse, and dispersal cycle directly. In a forward-pointing wave those offsets land on the unexpected side of the dust lane, an elegant, geometry-only prediction the maps can confirm. On the theory side, the offbeat carousel is a clean test of spiral persistence. Density wave orthodoxy argues for long-lived patterns that shepherd gas over many rotations, transient recurrent pictures emphasize short-lived, swing-amplified segments that constantly reform from noise and nudges. A disk simultaneously hosting a forward-phased outer duet and a trailing inner refrain lets both camps make risky predictions. If the outer mode is truly global, its phase should drift only slowly and its resonance ring should stay tidy. If it's transient, beat patterns should slide measurably over a few tens of millions of years and the ring's beat spacing should wander with local shear. Either way, the clock is on the sky in the ages of clusters and the spacing of the pearls. The clockwise pinwheel also clarifies how structure grows without drama. Bars are efficient engines for building central mass, but they are not the only route. Spiral torques, oval distortions, and resonance rings can feed a nucleus on a long simmer, adding a compact, disky layer over gigayears while leaving the outer disk largely unheated. That kind of quiet secular evolution leaves signatures more in phase space than in light, slightly colder orbits captured near resonances, gentle anisotropy in stellar dispersions where modes overlapped, and a lens-like brightness profile that mimics a weak bar when seen face-on. Catch these in the contrarian today and you have a template for reading them in more ordinary spirals tomorrow. Even the star cluster census turns diagnostic when the phasing flips. In most grand design spirals, the most massive clusters crowd just downstream of trailing shock ridges. In the reverse-winding outer lanes, the crowding should mirror across the dust crest. If compression is stronger on the inbound side of the ring, the high mass cutoff of the cluster mass function will rise there, and the brightest ultraviolet knots will skew to that sector. Track their disruption with age and you can watch how quickly the ring seeds the inner disk with unbound associations, a quiet migration that thickens the light without stirring the kinematics. Magnetohydrodynamics adds a non-trivial twist that the contrarian makes testable. Ordered fields strengthen with compression and rotate under shear. Cosmic ray electrons trace those fields in polarized radio continuum that typically sits offset from optical dust ridges on the downstream side, for trailing waves. In a forward-phased outer pattern, the polarized crest should flip to the other side, while the inner trailing mode keeps the classic arrangement. A single galaxy offering both geometries in one view is an A-B test few systems provide. Measuring that flip would tie magnetic alignment, shear, and arm sense together with unusual clarity. Scaling arguments keep expectations same. The survival time of a forward segment in a differentially rotating disk depends on shear, gas fraction, and disk responsiveness, TOMR-Q. Too hot, and the disturbance never amplifies. Too cold, and it fragments. The ringed contrarian sits in the sweet spot where swing amplification can sculpt a disturbance into a global-looking crest without tearing the fabric. That balance is almost certainly why the pattern looks dramatic yet the velocity field stays clean and near-axisymmetric, a stirred pond, not a storm. Environment supplies both the nudge and the limit. In a crowded neighborhood, slow flybys launch long wavelength lopsidedness while quick grazes rattle the outer gas and light up rings, but the same tides also erase delicate asymmetries over time. If the forward-phased outer duet was sparked by a small passerby, its lifetime will be set not just by internal shear but by whether further pokes arrive before it decays. A second, mistimed nudge could split the ring, seed a kink in the bead spacing, or even light a faint, one-armed distortion that rides above the two-armed chorus. Look far ahead and the epilogue remains coherent without being dull. As the external torque fades, the forward crests relax into trailing orthodoxy, the resonance ring dims or migrates as the pattern speed drifts, and the inner disc consolidates into a smoother lens while the bulge rounds imperceptibly. What survives longest are not the eye-catching asymmetries but the fossils, a flattened metallicity step where the ring once sat, a whisper of enhanced vertical dispersion where modes overlapped, a polarization field that still remembers past twists, and a generation of clusters whose ages increase with azimuth in only one direction, the direction a forward-phased past enforced. Call the subject the reverse-winding spiral, the ringed contrarian, the clockwise whirl, the Centaurus eccentric, labels are handles on the same idea. A spiral galaxy is a responsive medium that writes in the grammar of rotation, gravity, pressure, magnetism, and memory. Most chapters end in trailing arms because shear prefers them. Occasionally a well-timed line break flips the phase and the prose runs backward for a page or two. Reading that page while the ink is still wet is what makes this system more than a curiosity. It is a controlled experiment at cosmic scale, showing how a single sign change in a living disk rewrites the recent past and foreshadows the near future. What makes the clockwise whirl especially revealing is how cleanly it separates cause from effect across radius. Inside the ring, the orthodox spiral shepherds gas into lanes that behave the way textbooks predict, dust ridges mark gentle shocks, young clusters line up just downstream, and the flow crosses the arm with only modest streaming. Outside the ring, where the forward-phased mode holds court, those same ingredients rearrange. The shock still forms, but the sense of drift across the crest reverses, the age ladder tips the other way, the offsets between ultraviolet, H-alpha, mid-infrared, and radio continuum fall on the unexpected side of the dust ridge. It is as if the disk has drawn two diagrams on one canvas, one classic, one mirrored, inviting you to compare them line by line and watch phasing alone reshuffle the same underlying physics. Corotation is the hinge that makes the comparison precise. Inside that circle, material overtakes the wave, outside, the wave overtakes the material. Flip the wave's phase in the outskirts and you flip the sign of torque it exerts there. Gas just outside corotation, which in a trailing pattern would be braked and pushed slightly inward, is now gently sped up and nudged outward. Symmetric changes inside corotation adjust the inflow that feeds the resonance belt. Over a few rotation periods, those microscopic pushes accumulate into macroscopic rearrangements, denser beads along one sector of the ring, a slightly flattened metallicity step just inside it, and a mild lopsidedness in the outer light that never quite goes away until the driver fades. The contrarian also exposes how stars migrate without wrecking the disk. Near corotation, orbits exchange angular momentum with the pattern in a way that shifts their guiding centers while barely heating them, a quiet conveyor sometimes called churning. In the outer, forward-phased lanes, the sign of that exchange switches compared with a trailing case, so the azimuthal imprint in age and chemistry around corotation switches too. Long after the obvious geometry relaxes back to orthodoxy, that fossil remains. If you slice the disk by stellar age and stack the slices, you see subtle azimuthal modulations that still remember where the ring sat and which way the traffic once flowed. On small scales, the interstellar medium turns the ring into a laboratory of thresholds. Shear tries to stretch clouds, pressure and self-gravity try to hold them together. Where the balance tips just over the edge, collapse ignites and a bead forms. Where it hovers just below, clouds coagulate and shred without committing, feeding turbulence instead of stars. The tidy spacing of H2 knots along the belt is that compromise made visible. Measure the spacing and you infer the local tug-of-war, measure the offset between dust and ionized gas and you clock the collapse time, follow the mid-infrared glow and you catch the moment when newborn clusters begin heating the dust as they drift off the crest. Magnetic fields and cosmic rays, usually the quietest actors, speak loudly when geometry flips. Compression in the ring strengthens and aligns ordered fields, shear between the inner and outer modes twists them, supernova-driven turbulence tangles them again. The polarized radio ridge therefore sits offset from the optical dust lane, but on opposite sides for the forward outer wave and the trailing inner one. A single face-on disk thus offers an A-B test of magnetohydrodynamic alignment in two regimes at once, with the offsets and polarization angles acting as signposts for arm sense independent of extinction, inclination, or star formation clumpiness. The nucleus keeps time while the disk improvises. Mild torques from the spiral and an oval mass distribution trickle gas inward over hundreds of millions of years, layering a compact, disky component atop the older bulge and feeding a central black hole at a whisper. Even that quiet mass matters dynamically. It stiffens the inner potential, reflects waves, and helps the interior trailing mode hold shape while the outer forward mode runs its brief course. The result is secular evolution without spectacle, no dominant bar, no runaway starburst, just the slow, cumulative reshaping of orbits and light profiles that leaves a lens-like center and a slightly rounder bulge as durable souvenirs. Environment sets the tempo. In a crowded neighborhood, gentle flybys and minor captures arrive often enough to seed rings, lopsidedness, and brief leading segments without tearing a disk apart. The ringed contrarian looks exactly like a clean, off-center pass by a small intruder, enough torque to light a forward-phased outer duet and to brighten one sector of the ring, not enough violence to shatter symmetry or ignite global fireworks. Deep exposures at the faintest levels should still catch the chalk marks of that meeting, whispers of plumes, scalloped ripples, perhaps a barely one-armed excess, slowly fading as shear and mixing do their quiet work. Project the system forward and the epilogue is orderly rather than dramatic. As the external push ebbs, shear will unwind the forward crests into trailing lanes, the resonance belt will dim or drift as the pattern speed evolves, and the inner disk will settle further into a smooth lens while the bulge rounds a touch. What outlives the spectacle are the fossils in phase space and chemistry, a flattened metallicity step where the belt once circled, a whisper of enhanced vertical dispersion near the overlap of modes, polarization vectors that still hint at past twists, and a generation of clusters whose ages increase with azimuth in only one direction, the direction enforced by a forward-phased past. By then the nickname will matter less than the lesson it carried. Call this disk the reverse-winding spiral, the ringed contrarian, the clockwise pinwheel, the Centaurus eccentric. Each label is just a handle on the same durable idea. A spiral galaxy is a responsive medium that writes with the grammar of rotation, gravity, pressure, magnetism, and memory. Most sentences end in trailing arms because shear prefers them. Now and then a well-timed nudge flips a sign, and the prose runs, backward, for a page. Catching that page while the ink is still wet is the privilege this oddball offers, a direct, side-by-side view of how changing only the phase of a wave rewrites the recent history of a living disk.